Welcome to the new series of videos in the playlist MPMC lab. In the intro videos, I have given just names of some tools, what are the tools we are going to use in this lab, what are the different terminologies we will use in this lab, I mentioned in the intro video. So why to waste time, let's start a new series of videos, MPMC lab. I want to add two numbers. Number 1 is 07 and the number 2 is again 07. If I add these two numbers, the result is 7 plus 7 is 14 and if I take another type of number instead of this, 07H. The resultant of this addition is, I am performing addition here on all the three. The resultant of this number is 7 plus 7 will become E and the answer is EH. So you observe clearly here there is no extension, there is no indication. By default it is taken as decimal. So 7 plus 7 in decimal is equal to 14. And here by default the numbers which are of the form like this, zeros and ones, it is treated as a binary and need not mention that this is a binary number, and the resultant will become again a binary number. It is, if you convert this binary number into a decimal equivalent or hexadecimal equivalent, you will get the same answer. If you convert this to hexadecimal equivalent, this will become 0 and this will become E. 8 plus 4 plus 2. Right? So this 0 is this one and this is E. And here I clearly mentioned this is a hexadecimal number. So if there is nothing given to a number, it is decimal number. If there is nothing given to a number which is of the form zeros and ones, it's a binary number, or you can give B. And if H is given to the number, that is called as hexadecimal number. So these notations we'll use in assembly level language program. If you use a C language program, this number will be indicated by 0x07. This 0x indicates the number is hexadecimal number. Like similarly how H indicates the number is a hexadecimal number. So we have seen how to add two decimal numbers, how to add two binary numbers, and how to add two hexadecimal numbers. Now why I explain all these three additions? Because now I want a processor to do this task. Instead of we doing this kind of additions, now I want a processor to do this type of additions. Not only additions, we will ask the processor to do even subtraction, multiplication, division, etc. etc. So let us see first how to make a controller or a processor to do this kind of additions. So for that we are going to work with microcontroller 8051 and then microprocessor 8086. Name of the lab, that's why it is MPMC. In this lab we are going to see totally around 17 experiments as of now. Later I will add the experiments. So these 17 experiments list is experiment number 1 is to perform arithmetic and logical operations using various addressing modes. So before going to start directly this experiment, let me explain you some basics related to software development cycle. This experiment we are supposed to perform by using 8086 microprocessor. Same experiment we are going to perform for even microcontroller, but let us see one by one. So before starting this experiment, let me explain you one thing. I am writing a program in order for the microprocessor to tell that it has to perform addition of given two numbers. First, I have to write a program. That program can be written in two languages. One is assembly level language and the other one is C language. This assembly level language is called as a low level language, which is closely tied to the microprocessor or microcontrollers. I can say it as which is closely tied to the machine. C language is a high level language. Advantage of C language is we can write programs easily when compared to the assembly level language. If I want to write programs in assembly level language, I have to know the instructions of that particular device, either the processor or controller which I am using. So I have to learn instruction set of that particular processor to write programs in assembly level language. Here I need not remember much instructions. I have to remember just some of the registers of that particular processor or controller. I have to remember. So here we are going to see how to write programs right now in assembly level language only for microprocessor 8086. Later we will see how to write programs in C language for processors and controllers. So I am using a assembly level language to write a program. That file looks like file.asm. What I mean that file looks like is this file will take the extension .asm. If I write a normal file with extension .txt, it will become a text file. .docx or doc will become a Word document. XLSX will become a Excel sheet. So like that, assembly level language program will take extension .asm. So I am writing a program in assembly level language which is file.asm. This file.asm is a user understandable file. I can understand to some extent by remembering by reading the instructions of the processor. But the machine does not understand this. Your microprocessor cannot understand the language which you wrote by using assembly level language program. So this file.asm is not a user understandable program. Then what? Not a machine understandable program. What a machine understands is only exe files. Like it will understand file.exe only. I cannot write program in exe. It is highly difficult for us to write a program. Sorry for disturbance. It is highly difficult for us to write a program in a machine understandable file. We cannot write programs in machine understandable format. Machine cannot understand our program. So to solve this problem, what we will do is we will depend upon a mediator who can convert this assembly level language file into an executable file. Such a software is your assembler. Assembler will convert this file.asm to file.obj. Who is converting? Assembler is converting this. It is converting file.asm, user understandable program, into an object file. And by using another software, linker, we can convert this object file into a machine understandable file, that is file.exe. This linker is a software which will link the object file which is generated by the assembler with the object files available in the library and give you exe. So just remember that I need two softwares. One software is assembler, which can convert assembly language file to object file. Another software is linker, that can convert object files to exe file. Now this exe file is machine understandable. In order to debug this exe file, here I will get whether there are any errors in the program or not. This assembler will tell me if there are any compilation, errors at the time of assembling the program. But there may be some errors which cannot be seen at the time of assembling. So such kind of runtime errors can be identified by debugging the program first. So debugging can be done by using a software debugger. So these are the three tools I want. One tool is assembler, second one is linker, and third one is debugger. Assembler will generate object file, linker will give you executable file, debugger will test this executable file. It will debug that program to verify if there are any runtime errors are available. If there are no runtime errors, then directly you can dump this exe file into the microprocessor or microcontroller's memory and run the program on that. Right? So, in order to continue to write this program for the processor 8086, we are using the software MASM. This MASM is an assembler. It belongs to Microsoft, so its abbreviation is Microsoft's Macro Assembler. The name of the assembler we are using is MASM. The name of the linker we are using is link. And the name of the debugger we are using is debug. As I said, these are the softwares. They have extension masm.exe, link.exe, and debug.exe. These three files together, I will put it in a folder called MASM. You can give any name to the folder. I am giving a name to that folder as MASM, and I kept in these three softwares: masm.exe, link.exe, debug.exe. These are the three softwares, very small softwares. You need not even install, just put these three softwares in a folder called MASM, and using the disk operating system, enter into this folder. Like if you put this folder in D drive, enter into the D drive and then go change directly to MASM. Now you start working with your programs. So this I will explain in the software part, and in the system I will show you how to enter into the disk operating system. To summarize, we are using three softwares. One is MASM, an assembler which is used to assemble the program, linker, link, which is used to generate executable files, and then debugger is used to debug the program. Let us see how to write the program now. For the microprocessor 8086, we have to write two segments. One is code segment and the other one is data segment. So let me explain you what is the code and what is the data. I want to add two numbers, 07 and then 07, hexadecimal numbers. So because system will accept only hexadecimal numbers. So let us give the input hexadecimal number only. So I want to add these two numbers. So these two numbers will become data for me. The result of this addition is also again a number, that is also a data. Now in order to tell the processor how to do this type of addition, I will be writing a program, right? So there are some 7 number of lines in the program. So these 7 number of lines which will tell the processor how to add these two numbers will become code. So code is a program, a software instruction which is written to explain or to tell the processor how to add the given two numbers. So the two numbers will become data and this will become our code. So actually this microprocessor 8086 will use 4 segments. One is code segment, other one is data segment, third one is extra segment, and fourth one is stack segment. There are 4 segment registers: code segment, data segment, extra segment, stack segment. These segment registers will help us to access code segment, data segment, extra segment and stack segment, which we will discuss later. Right now you just remember that there are 4 registers which are CS, DS, ES, SS called as segment registers. They will be useful to access this respective segment like data and code. Data segment can be accessed by DS register, code segment can be accessed by CS register. So in the program I need to create 2 segments. Segment can be created by using a keyword called segment. This is actually called as an assembler directive, which will create a particular segment. I want to create a segment with the name, say for example, HANU 7 segment I want to create. So if you want to create this particular segment, just write that name and in front of that you write segment. This segment will be created. Inside the segment I want to define my data. I want to write A. I want to give a name to the first number A. This number is a 8-bit number. This is a 8-bit number. If you convert this to binary, you can see there will be 0, zeros and 0, 1, 1, 1. I showed you just now. So it is a 8-bit number. So in order to tell the microprocessor to allocate 8 bits of memory to store this number, I have to write another assembler directive called DB. DB will tell that I have to allocate, that means processor has to allocate 7 bits to store this data in the computer's memory. And this data can be called by, accessed by the name A. So this A is a variable. HANU 7 is also a variable, you can give any name. A is also a variable. But these two are fixed, they are keywords, they are assembler directives. So I define my first number, second B, DB 07H. So I want to add only 2 numbers. I am done with my data. So let me close my data segment. HANU 7 NDS. This NDS is also a keyword. I am underlining the keywords which are assembler directives for us now. NDS indicates end of the segment. I have created a segment. I am telling that this is the end of the segment. So data segment is done. Now coming to the code segment. So instead of writing code as the name, I want to write something else. I will give a name for code segment as U2 because it's a variable, I can use any name. So I want to write U2 segment. As soon as I start this segment, I have indicated that my code is starting from 1000 memory. There is inside the code segment there are 64k locations. You have to clearly tell that in which location your code is going to start. So I am indicating that code starts from 1000 memory. This is also a keyword. ORG 1000. If you don't write this also, nothing will happen. It will by default take the address as 0000. From there your code starts. If you want to specify a particular address, write it. And to symbolically indicate that my program starts from this place, so write a name, a variable start and put column before that. This will become a label. In assembly level language, whatever you write and put column, it will become a label. So in this label you write down your program. So first statement in your all programs of microprocessor is move. Move is an instruction which will tell how to move the data from one place to other place. So move AX comma you have to write the data segment name. What is my data segment name? My data segment name is HANU 7. So move AX comma HANU 7 and then move DS comma AX. So what did I do here is, whatever the address of my data segment HANU 7 is there, that address I have to give to the data segment register. Then only this data will be accessible. Otherwise it will add the default data available in the computer's memory. So by default DS will be allocated by some default data segment address which is especially called as segment base address. So in order to tell that you have to access this particular data, I have to give the address of this anu7 to ds. So I have to write like this, move ds comma anu7, but that is not possible. Immediate moving of a number into segment register is not possible. That's why I moved this to temporarily to AX register. From AX I sent it to DS register. So what is this AX? Again came into the picture is there are 4 more registers, AX, BX, CX and DX. These are called as general purpose registers. These are segment registers and these are general purpose registers. AX is accumulator, BX is a base register, CX is a counter register and DX is a destination register or data register. So I temporarily copied that address of anu7 into AX and then from that I copied into DS. This is an allowed step. So I did indirectly. Instead of directly sending the address of anu7 to DS, I copied from AX to DS. So simply remember that these are the 2 common statements which you have to write. Write move AX comma data segment name, move DS comma X. These are the common steps for all programs. Now coming to the first step of your program. In order to add your 2 numbers, first copy the first number into AX register. Move AX comma A. My first number is A. So that number 7 will go into AX. Similarly, copy the second number into any register. I can use BX, CX or DX. But this AX is mandatory. AX should be involved in all arithmetic and logical operations. Without AX, there is no arithmetic and logical operations. So because that AX should be involved, let's send one number to AX. Then you can choose any register. I will take BX, comma B. But here there is a drawback. If you write a program like this, AX comma A, BX comma B, you will get an error for this statement and this statement. What will be the error is, your A is a 8-bit number. I am trying to send that 8-bit number into a 16-bit register. So this is not a good practice. So what we have to do is, we have to take AX is divided into 2 parts, AL and AH, both of 8-bit and 8-bit. So because we are working with 8-bit number, write down here AL instead of AX. Similarly here, BL instead of BX. That means I am using only the 8-bit register, not complete 16-bit register. If you are working with a 16-bit number like 1007, then we will write DW here and then we will use AX and BX here. I hope you are getting this point. If not, you can put it in the comment section. If there are any doubts, you can raise in the comment section. I will feel free to explain even in the comment section why only AL is taken, why AX is not taken here. Now after this, the immediate next step is addition. I got 2 numbers, right? Then take addition. So in order to perform addition, I know there is an instruction add. In order to move, I know there is instruction move. So I am using move instruction as of now. Move will take a format like this. Move will be having 2 operands. This is called source operand. This is a destination operand. Similarly, you can observe for all move there are 2 operands, source and destination. Similarly, addition will also have 2 operands. One is the source and the other one is the destination. But what is the rule is, addition will always take accumulator as the destination and source can be any. Right? So I will write similarly add AL. AL is accumulator, which is the destination, and BL. So we are done with addition. My intention is I want to write a program for addition. It is done. So let us stop the program. Let us ask the microcontroller or microprocessor, sorry, not microcontroller. Let us ask or instruct the microprocessor to stop executing the program. So that can be done like this. Excuse me. After this statement, immediate next one is, I am writing here, I will write int 3h. Because addition is done, I am indicating the processor to stop here. This is a breakpoint interrupt. Int 3h is called as a breakpoint interrupt. The controller will stop executing the program at this point of time. Right? So after telling the processor to stop, at this line, then you have to close your segment also. Your segment name is U2 and S. Like how did you create a segment and close the segment? Similarly, you have to close this particular segment U2. So U2 and S, and then end start, because you have indicated there is a start label. So I am telling clearly that my program is done, end start. So start, we wrote first two statements called data segment initialization steps, moving the first number into AL, second number into BL, addition, and then breakpoint interrupt, then closing the particular code segment, and then indicating end of the program. So this is how we will write a program to add two numbers. Two are 8-bit numbers here. This is my data, 7 and 7 is my data, and this program whatever I wrote is called code. But even assembler don't know whether Anu7 is code segment or U2 is a code segment. So you have to tell clearly what is code segment in your program. So you have to write assume. This assume is also an assembler directive. Assume, I have to tell code segment in my program is U2. Data segment in my program is Anu7. One more point is this assembly level language program is not case sensitive. You can use small letters or capital letter. That's why I used Y and T small letters here. Okay. So CS colon U2 comma DS colon Anu7. It is telling the assembler that my data segment is Anu7 and my code segment is U2. So this is how we will write a program for the microprocessor 8086 to add given two numbers. So if you want to write a program for subtraction, just replace this addition with SUV. It will perform subtraction on the given two numbers. Same program as it is, only the changes. Just I replace addition with subtraction. The format for subtraction is similar to addition. And coming to the multiplication also saying I will replace mul, I will replace sub with MUL, but multiplication will take a different format when compared to the addition and subtraction. It will take only one operand, that is especially source operand. AL is taken implicitly here. I need not specify what is my source. Like that, I will write mul BL. And if you want to perform division, just replace mul with DAV. It will perform division. So see how what we learned just now. We wrote a program now for addition, subtraction, multiplication and division. Only the changes here. Entire program remains same. And if you want to work with 16-bit numbers instead of 8-bit numbers, just replace this DB with DW and give your 16-bit number. This is my 16-bit number I want to add. Same steps, everything is same, but here it will change to AX, it will change to BX as I already explained, and this will become DX. Right? So in the software part, that is while explaining how to work with MASM software, there I will explain you where you can see the result also in the computer screen.
That's all for today. Thanks for watching. For more videos, subscribe to my channel. Thank you.